Hi, I'm Isaac Domaratsky, founder of PLAyI. This is a presentation of the PLAyI system, an AI-powered server-sided graphics rendering system for gaming that exceeds what is possible on current client-sided devices powered by traditional graphics cards. PLAyI makes high-quality lightning-fast graphics possible without the reliance on a client's hardware. I'm about to run through a proof of concept demonstrating the PLAyI system. Please note that this has been designed so none of the underlying mechanics can be replicated by a third party and runs on emulated server hardware. Here are some key differences that make PLAyI a revolutionary system for processing game graphics as compared to client-sided processing. Traditional game rendering requires the computation of polys, animations, and 3D rendering. However, the PLAyI system is non-poly based and can provide more detailed models to improve player experience and give artists greater creative flexibility. The PLAyI system is developed with current hardware in mind and is currently application-based, meaning ease of compatibility for users. However, there is a huge room for further optimizations. Hardware can be developed to further increase optimization of the AI by approximately 80 to 90%. First, we are going to see how the current paradigm of graphics rendering handles polys. We're using cubes as this is a simple representation of a 3D model, so we can gauge how the current system handles computing just simple geometry without other aspects such as lighting, texturing, shadows, etc. I'm going to spawn an increasing number of cubes, each formed from 12 tries, with each try being a polygon. We will rotate them to demonstrate how the current system of graphics rendering struggles when working with a lot of polygons. Even simple geometry, such as the cube, requires a hefty computational load when rendered on the screen in large quantities. I would like you to pay attention to the frames per second indicator in the top right corner as we manipulate these cubes in simulated space, and also the smoothness, or lack thereof, of the rotation of these cubes. The frames per second is the definitive marker of how the system is coping under the computational load. Okay, so now we are going to enter the sim and see how a regular computer and how rendering powered by a GPU handles the computations of the geometry of a cube. So we've got this first cube spawned and the computer handles it perfectly. 25 cubes, 5 rows by 5 columns. We see a little bit of performance slow, but not too much. However, when we do get to 10 by 10 or 100 cubes, you can see that the computations really slow down and it really starts to affect frame rate. We start transforming these cubes, i.e. rotating them. Next, we're going to compare the previous system with the PLAyI system. While the previous system wasn't developed with gaming in mind, PLAyI is. We're going to perform the same process using the PLAyI system and its Renaissance AI. Again, please pay close attention to the frames per second and the smoothness of the rotation. When Renaissance reaches 100% confidence in replicating the cube on screen, my assistant will appear to indicate that learning has completed. The model has been trained in real time through user input in the simulation just so you can see how fast Renaissance learns. Our cube is automatically replaced with our AI generated cube. As you can see, it performs exactly the same way when rendered to the screen. But now we are going to test the upper limit that the regular system of rendering was having trouble with rendering and keeping a steady frame rate. And here you have the 100 cubes, all individual objects with their own individual game properties, such as collision and health, amongst a few other things. You may notice that the aspect ratio has changed a little bit. That's because Renaissance learns at 4K and it downscales to the native aspect ratio of the user's client. And if you'd care to rewind, you'll also notice that I'm whipping around the rotation at a much higher speed than I was able to with the regular computing of the geometry. Note how the frames per second stays at a consistently higher value overall as compared to the traditional system. Also note the smoothness of the cube rotations even at higher rotation speeds. Now, in closing, I'd like to extrapolate the implications of the PLAyI system. As the PLAyI system doesn't have to deal with a poly limit, it will allow for all models to be highly detailed with high fidelity. Higher detailed and more lifelike graphics than currently achievable by any user device. No draw distance, meaning high detailed graphics even at a distance. No extraneous computational overhead for complicated lighting systems, as it's all baked into the AI. As there is no reliance on user end hardware, there will be more widespread access for gamers to play the best looking games without needing expensive components. This also unlocks the ability to have high fidelity gaming experiences on mobile, tablet, and handheld devices. Without the reliance on powerful physical graphics cards, as well as fewer processes happening client-side, the system is more power efficient, sustainable, better for the environment, and will save the users money on their power bills. Thank you for watching this technical demonstration of the PLAyI system. If you have any questions, please contact me at id@playi.tech.